Hello everybody, my name is Michael and welcome back to my channel. Hope you're having a wonderful day so far. We're going to be jumping back into Harvard CS50X for 2025, more specifically into Week 1, Lecture 1 on C. In Week 0, or the previous lecture, we learned about basic computer science topics such as bits and bytes, how colors, images, and videos are processed and displayed to us, and given a basic introduction to some general coding principles such as functions, loops, conditionals, and booleans. And for our problem set 0 for that week, we completed a project in Scratch. If you want to get access to all my resources, including that problem set, please join my Discord where I provide that all. Link down below. Let's jump back into CS50X 2025 Week 1, Lecture 1 on C.
So up until now, we've been calling a string of text literally a string. And this is common in many programming languages, including Python and JavaScript. Strings in the programming world just mean text, whether it's 0 or more characters thereof. But C does have other data types, just a few of which we'll dabble with today, but you'll use more over time. We've already seen string, for instance, which is indeed a string of text. But let's focus as well on like an integer. As an aside, there's other types too. There's Boolean values, like true or false. There's chars, which are single characters instead of full phrases or sentences. There's doubles and floats, which are real numbers, something with a decimal point, the equivalent of fractions. And there's longs, which are integers, but like longer integers, even bigger integers than you might type by default. So let's focus on an int, because so many computer programs, of course, manipulate numbers in some way. So what can we do with this? Well, if we want to be able to get an integer, lucky enough, CS50's library comes not just with getString, but also getInt. So that's going to be a third function we now use in C. And we need to know these, what were generally called format codes. So that placeholder I called before %s is indeed for a string. If we want to place an integer inside of something we're printing to the screen, we are, in fact, going to use %i instead. So let's now actually use these building blocks, getInt and %i, to actually get numbers in some way to sort of solve a problem. Well, what problem could we solve? Let's introduce another concept from scratch and programming more generally known as conditionals, like those proverbial forks in the road. If something is true, do this. Else, maybe do this other thing. So in Scratch, we might have had a set of puzzle pieces that looked like this. If x is less than y, then say, or have the cat say, x is less than y. So it's sort of stupid program, but it just demonstrates how we have two variables, x and y, in the context of Scratch. We're comparing them with a Boolean expression. We're using a conditional to then conditionally say or not say this phrase here, depending on whether this question has an answer of true or false, yes or no. In C, it doesn't look all that different. It's a little more cryptic, but you say literally if. You use parentheses, similar to functions, but confusingly by convention, you put a space after the word if. So you don't put spaces after function names. You do put spaces after words like if. And you use the parentheses to conjure up this weird trapezoidal-like shape. So there's no real keys that kind of conjure that. So C uses parentheses, like most languages. And then there's these weird curly braces, which at least in English, we don't use all that often. But they're there on your keyboard, English or otherwise. And they essentially allow us to create this sort of hugging shape to the puzzle piece. Anything inside of those curly braces is going to be equivalent to anything inside of this yellow hug that's sort of grabbing one or more pieces inside. So what do we put inside? Well, this part is straightforward. Printf, quote unquote, x is less than y, \n, semicolon. So nothing new here. The only bit of new code is this if construct instead. What if you have an if else? So a two-way fork in the road. This is what that looked like in Scratch. Same question. If x is less than y, then say x is less than y. Else, say x is not less than y. In C, the code is going to be set up initially like this. So two sets of curly braces to represent this pair of yellow bars and this pair of yellow bars. And what's inside of them, indented no less, just like our pseudocode last week, is two printfs. X is less than y, x is not less than y. So that's it. So the only new stuff here really is now the else keyword, which does not need parentheses because you're just saying else do this other thing. But what if it's a three-way fork in the road? And we'll stop after that. Here's a three-way fork in the road in Scratch. If x is less than y, then say this. Else, if x is greater than y, say this. Else, if x equals y, then say this. So this is a little more precise because now we're handling equality, not just greater than or the opposite. In C, it's going to look similar to before, but we're adding this element here. And at first glance, especially if you've never programmed before, it looks like I'm an idiot and I made a typo. What looks wrong? There's like two equal signs, like not a typo. So it turns out, recall from earlier, when we use the equal sign the first time around, we used it in the context of getting a return value back from a function, like the getString function handed me back the user's answer. So unfortunately, because humans decades ago decided, hey, let's use the equal sign to assign a return value from the right-hand side of a line of code to the left-hand side, we sort of painted ourselves into a corner and like, oh, shoot, what do we do when we actually want to test for equality of two values on the left and right? So what most languages, including C, do is use double equal signs. So you can say double equals or equals equals or whatever, but it is, in fact, syntactically correct. What's inside of these three sets of curly braces? Same idea, printf, 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 based on what English phrase you want to print out. So this code, both in Scratch and C, I'll claim is correct. It won't run because we still need like the other stuff, the equivalent of the when green flag clicked. But out of context, this code is correct. But there's a subtle weakness in design. And we'll talk a lot about this week and beyond. Correctness just means the code does what it's supposed to do. Design is more subjective, like how well have you written your argument in an English paper? How well have you written your code is design. This code is not designed as well as it could be because I'm doing more work than I need to. Yeah, and back.
You don't need to do it.
Yeah, I don't need the x equals y, but why, logically?
Because if it's not greater than or less than, it has to be equal to, if it's an integer.
Exactly. That's just a math thing. Like either x is less than y, or it's greater than y, or the third and final option is they must be equal. So it's subtle, but why would you bother wasting time writing a line of code and expecting the computer to run a line of code that is just going to answer a question that logically you could have concluded already? Because if x is not less than y and x is not greater than y, then my God, just print out x is equal to y, because you know at that point, logically, it's true. You don't need to waste your time or the computer's asking a third question unnecessarily. In reality, it's not a huge deal. No one's going to notice in the real world on a Mac or PC that there's this extra line of code, but it's a bad habit. Keep it simple. Don't write code that doesn't need to be there if logically you can conclude otherwise. So in fact, let's clean this up both in Scratch and in C. I can tighten this up, so to speak, use less code here, less code here, and honestly, if only statistically, the less code I write, the less likely I am going to make mistakes. So that too is probably a net positive overall. Writing less code is generally better than writing more code, not unlike English essays too, perhaps. All right, questions about this feature of C, conditionals, and this syntax? Yeah. Oh, a really good question. And yes, jumping the gun, there are alternative ways to solve problems like these. And the question was, to summarize, when to use if, else versus what's called a switch statement. More on those another time. But this is going to be true in general in programming, not just C, not just in Scratch, but every language. There are going to be several, dozens, hundreds, an infinite number of ways to solve problems. Among the things we're going to teach you, though, is indeed how to do things well or better than you might otherwise. And we're going to introduce you eventually to another feature of the language that can even simplify this code too. So for now, let's actually use this then. So let me go over to VS Code again. I'm going to go ahead now and clear my terminal window. Down here, I'm going to go ahead and close the hello.c tab, just so that we're going to create a new program. And let's just do something a little simple using some operators, so to speak. And I haven't used this word by name, but it turns out that there's lots of operators that come with C, just like a lot of operators that came with Scratch for doing assignment, or less than or equal to, greater than or equal to, actually equal to, not equal to. Now, some of these are a little cryptic, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what most programming languages do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use two characters. So greater than or equal is literally this. Less than or equal is literally this. We already saw that equals is this. And not equals is to use an exclamation point. So this too is a thing in programming. Using the exclamation point, pronounced bang, is how you invert logically certain things. So bang equals or not equals is how you would express exactly that idea. It's just a symbol on the keyboard that some human decided, let's use this one to invert the idea. But we're going to need one other thing for this program, specifically variables, which we've used already sort of because in Scratch we got one for free, we had that answer variable that stored the return value of the ask block. But let's consider in general how you can, and probably did for problems at 0, use a variable of your own, like keeping track of a counter or a score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound? You have to tell the computer that this is an integer, otherwise written as int for short in C. But there's one other stupid detail that's missing, which is now semicolon to finish the thought here. But this then is equivalent to this in Scratch. Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now at a glance, this seems like a paradox of sorts. Like, how can counter equal counter plus 1? Like, I can't make that math expression true, but it's not math in this case. The single equal sign is assignment. So this means take the current value of counter, whatever it is, add 1 to it, and then copy that value from right to left into the same variable, thereby changing it from 1 to 2, 2 to 3, and so forth. This, though, is so common in programming to be able to increment or even decrement numbers by 1 or 2 or more, is that you can tighten it like this. This is the exact same thing, a little faster to type, saves you keystrokes, maybe less chance for error. Counter plus equals 1 semicolon is the exact same idea. Better still, this is so common in C and C++ and Java that there's a third way to do this. To my comment earlier about solving problems in different ways, the most canonical, the most popular way is probably just to say counter plus plus semicolon, which literally automatically adds 1 to that value. Only works for 1. If you want to do 2 or 3 or some other increment, you have to use one of the other approaches. But this simply does the same thing as this. And if you want to invert it to -1, you change the plus plus to a minus minus instead. So again, just little things that we'll see and pick up over time. Invariably, you'll have to look them up or check the notes or look back at the lecture slides. But in time, this will get familiar if you are not already familiar. So let's consider just logically how we might implement this in code. Let's go back to VS Code here, and let me propose that we create a program called compare.c, whose purpose in life is just to compare a couple of values. I'm going to go ahead and proactively, based on the previous chats, include CS50's library from the get-go. I'm going to include standard io.h from the get-go, so I can use getInt and printf respectively. I'm going to just on faith type int main void. And today, we won't explain what that does. More on that to come. For now, just assume it's like when green flag clicked. But in this program, let's do a couple of things. Let's declare an integer called x and assign it the return value of getInt. And let's just keep it simple. Let's ask the user not what's their name, but what's x question mark, semicolon. Now, so that we have something to compare, let's do it again, but with y. Int y equals getInt, quote unquote, what's y question mark. And I'm leaving, again, a space just visually so the cursor nudges over a bit, followed by a semicolon. At this point in the story, my users will be prompted for x and y respectively. Let's do something with those values. How about if x is less than y, then go ahead and print out, quote unquote, x is less than y \n, close quote, semicolon. All right, and let me hide my terminal window for just a moment. This is a 13-line program at the moment, but really it's like 5 or 6 interesting lines. The rest has been copy-paste from previous programs. Notice a few details. One, I've indeed used my curly braces here. And notice if you highlight lines, you'll actually see little dots that can help you make sure, oh, there are indeed 4 spaces there. I've been indenting, just like we did last week with pseudocode. Strictly speaking, it's not necessary, but it's going to be way easier to read your code if you do add all of this white space, so to speak, than if you write and then submit to us as homework a program that looks sort of god-awful like this, which is going to make it much, much harder for the human to read it, for you to read it, your colleagues in the real world to read it, but the computer is actually not going to care. In fact, as an aside, one of the tools we have built into VS Code for CS50 is this button at top called Style50. This is a program that we indeed wrote that will give you suggestions on how to improve the style of your code so it looks like the right way that programmers would generally write it. As an aside, the computer world is fraught with like religious debate, so to speak, as to like what code should look like. And people in the real world will have really stupid arguments over how many spaces to use for indentation and what lines code should go on and so forth. Generally, in the real world or in a class, there's an official style guide that someone sort of autocratically declares this is how everyone should write their code, so that just everyone's code in the company or course looks the same. But you'll find in the real world, reasonable people will disagree. When you click Style 50, it will be formatted as we ourselves recommend in CS50. And in fact, let me zoom out here. And this looks a little cryptic at first glance, but on the left is the code that I just wrote and made a mess of by deleting all that white space. On the right is the way the code should look if it is well styled. So whereas correctness is all about, does the code work the way it's supposed to? Design is about, how well have you written that code? Is it efficient? Did you make good decisions? Style is purely aesthetic. Is it readable? Does it follow a standard? Can another human sort of easily skim it top to bottom, left to right, and understand what's going on? So these green highlights are saying, please add white space there. And so I can actually change my code to match. On the left-hand side here, if I realize, oh, my code's looking pretty ugly, watch on line 6 at left as I hit the space bar to, whoops, sorry, on the left, 1, 2, 3, 4. Notice that the right-hand side is starting to be happier with my code by getting rid of the green indicators. And I can do 1, 2, 3, 4. That fixed that. Over here, I can do 1, 2, 3, 4. I can move this onto its own line by hitting Enter. And you know what? If it's taking too long, once you get into the habit of things, you can just apply changes. It will give you the suggestions automatically, and we're done and on our way. But for practice's sake, I would get into the habit of doing things manually until it gets boring and tedious, and at which point you might as well automate the process with a single click. All right, so let's actually run this code. I'm going to go ahead and open my terminal window again and clear it for clarity. I'm going to run make compare and hope that I didn't make any mistakes. I don't seem to have yet. /compare. And now notice I'm prompted for x, let's type 1. For y, let's type 2. Enter. And x is less than y. Let's do a little sanity check, so to speak. Let's rerun it. /compare. What's x? Let's do 2 this time. 1 for y. And this time it said nothing. So that's to be expected, because I didn't have a 2-way or a 3-way fork in the road. The only time this code should say anything is if indeed x is less than y. So for those of you who might be more visual when it comes to learning, here's a flow chart that represents this same exact program. If you read it top to bottom, you start the program with /compare. You are then prompted for x and y. And you're asked this, is x less than y? And the fact that this is a diamond means this is a Boolean expression, a question that the computer is asking itself. If the answer to that question is true, then quote unquote, x is less than y gets printed and the program stops. Else, if x is not less than y, as in the second scenario, the answer is of course false and nothing more happens. But we can build out this tree, so to speak, by adding a bit more code. So let's make it look like the second Scratch example. If I go back here, it's not hard to just say else if x is not less than y, let's say that. X is not less than y, \n, close quote, semicolon. Let me now go ahead and rerun, make compare, enter, /compare, enter. And again, I'll do the second example. 2, which is bigger, and 1, which is smaller. And this time, I will see x is not less than y. If then we were to look not at this flow chart, but a slightly bigger one, you can sort of visualize it this way. Everything on the left-hand side of this picture is the same. But if it's not true that x is less than y, the answer is thus false. This time we say, quote unquote, x is not less than y. And we can do this obviously one final time just to bring the point home. If I go back to my code and I even more pedantically compare these 3 values, let me go ahead and do this. So else, I don't want an else actually, so let's go ahead and do this. Else if x is greater than y, let's then say x is greater than y in English. And then finally have an else that says print f x is equal to y, close quote, or rather \n, close quote, semicolon. So just to show this all on the screen at once, this is identical now to that Scratch version. It's well designed because I'm not asking the equals equals question unnecessarily. If I go back to my terminal window here, clear the screen, run make compare, enter, and then /compare again, enter. What's x? Let's do 1. Let's do 2. X is less than y. Let's run it again. /compare. What's 2 and 1? X is greater than y. Once more time. /compare. What's x? 1. What's y? 1. And now x is equal to y. As an aside, if I seem to be typing fairly fast, you can actually kind of cheat with your keyboard. If you go up or down, you can scroll through all of the past commands that you've typed. So it's actually, very useful. If you just hit up, it will pre-write the previous command for you, at which point you can just say enter. Or there's other fancy features built into this programming environment. If you do /com and then get kind of bored with typing out the whole English word, you can hit tab for tab completion, like in a web browser, and it too will autocomplete if it finds a file that starts with those letters. So a design question. So this code, I dare say, is correct. Let me zoom in a little bit here. Let me change the code to just do this, even though we already saw from scratch that we probably shouldn't do this. Why should we not do this if, especially, I'm just more comfortable asking 3 separate questions, like if x is less than y, if x is greater than y, if x equals y, do this. Like, it's a nice world to live in. Just ask your questions.
Going to ask that question no matter what for each condition.
Just ask 3 questions, but let's
it's
put a finger on why is this correct? Yes,
is satisfied
well
somewhere down the chain, then it will exit out. Rather than just 3 ifs, where each of them will be checked.
OK, there could be cases that are potentially outside of these 3. Because this is relatively simple math comparing numbers, like we don't have to worry about that here. But yes, in general, you might miss a scenario without using a catch-all like else. Yeah, so maybe more than one of them could be evaluated as true. Not going to happen here, but yes, you could accidentally create a situation where 2 things print or 3 things print because you didn't really think about the boundaries among these questions that you're asking. Again, not applicable here, but in general, a good concern. Really good. Really what's concerning here in this example is you're slowing the computer down by wasting its time having it do work that is logically unnecessary, even more so than the scratch in the first C example. Why? Suppose that I type in 1 for x and 1 for y. Because I wrote this code top to bottom, this question is going to be asked no matter what. The answer is going to be false. This question is going to be asked no matter what. The answer is going to be false. This question is going to be asked, and no matter what, the answer is going to be true. We're OK there, because we had to ask all 3 questions. But suppose I did the first thing. X is 1, y is 2. Then this first question is going to be true, because x is less than y, 1 is less than 2. So this is going to print. And yet then I'm wasting everyone's time asking, is x greater than y? Even though it obviously isn't. Is x equal to y? It obviously isn't. You're adding you're doing 3 times as much work in that particular case. It's just not good design. And again, for those of you who think a little more visually, we can actually make this picture to match. Here is a final flow chart for bad code, bad design. Why? Because no matter what, when you start the program and you want to stop the program, you're going through all 3 of those darn questions no matter what. Whereas the previous flow charts got us to the stop bubble faster by taking alternative arrows based on true or false answers. So in short, still correct, but bad design. And so again, even for problem set 1, when we start writing C code, consider not just getting the job done, but how you might get the job done better than you might otherwise. All right, let's add a few other features into the mix. Here we have those same data types that are supported by C. Let's focus for a moment on something a little simpler, just chars, single characters. Unfortunately, for better or for worse in C, the language makes a distinction between strings of text, which are generally words, phrases. They can, confusingly, be single characters or even 0 characters if you don't type anything in between the quotes, but more on that another time. But when you know from the get-go that you only want to get a single character back from the user, like Y for yes, N for no, for instance, which is super common in programs, you can get that using a char and CS50's own function, getChar. So how might we use this? Well, let's go back to VS Code here. I'm going to close compare.c, and let's write a third program altogether. Let's call this one agree.c. And this is meant to represent like terms and conditions where you have to check a box yes or no or something like that. In this program, I'm going to go ahead and do the following. I'm going to go ahead and, as before, include CS50.h, so we've got it, include standard io.h so that we've got it. Int main void, because we have to do that for now. More on that another time. And now let's ask the user a question. Do they agree? So I'm going to call get char and then pass in a prompt of do you agree question mark with a space, semicolon. But as before, with getString and getInt, those functions return a value. So I want to assign that value from right to left to a variable, which I could call answer again. But honestly, this program's so short, we're just going to use the letter C, which is conventional. So C for char, I for int, or N for number are very common. But one more thing, what's still missing for my variable here? The type. I need to say this shall be a char, not an int, not a string, a single char. All right, now what do I want to do? I can ask a question. If C equals lowercase y, then go ahead and print out, just so we see something on the screen, agreed period backslash n, as though they agreed to the terms and conditions. Else, if C equals lowercase n, go ahead and print out, for instance, not agreed, just so we see something on the screen. So let me hide my terminal window and focus on the code. There's a couple of details here that are a little interesting. So one, what did I do on lines 7 and 11 that is not consistent with what I've done before? Subtle.
Quoted
So I'm using
char.
apostrophes or single quotes now
Because
instead
it's
of
a
double
char.
quotes. Why? It's a C thing. When you're using strings, you use double quotes. When you use single chars, you use single quotes. So the argument to get char, that's still a string. It's a whole sentence that I'm passing in. So that is just like get int, just like get string. But when I get the answer back, the return value, and put it in this variable, and I want to check what is that one char, I have to surround the char I'm comparing against in single quotes or apostrophes, both for the y and for the n. So this program's not super well designed because it's not going to handle uppercase. It's not going to handle weird inputs very well. But let me open my terminal window, make agree, enter. The code compiles OK, /agree. Do I agree? Let's try it. Y for yes. OK. Let's try it again. /agree. N for no. Not agreed. Let's do it one more time. Let's very enthusiastically say yes in all caps. And it just kind of ignores me. But why? Well, this is a feature of CS50's getChar function. If you tell us you want to get a char, we're not going to tolerate a whole string of text from the user. We're going to prompt them again and again and again until they give us just one char. So yes is 3 times too long. So let's actually just do a single capital Y and see what happens. Return. The program ignores me altogether. So all right, this is kind of a poorly designed program. It's a little annoying that we'll just ignore humans, even if they type in Y or N that just happens to be uppercase. So let's improve this. Let me go ahead and add a couple more conditions. Else if C equals uppercase Y, then go ahead and print out agreed, same as before. And then down here, else if C equals capital N, then let's go ahead and print out again, not agreed. So this is now more correct. It's still going to ignore bogus input. That makes no sense if it's just like the word, if it's a different letter altogether. But this to code, while more correct in some sense, is still poorly designed. Even if you've never programmed before, what rubs you the wrong way about this code now?
We're giving two agree options when we could just combine them to one single if this and this or this.
Yeah, it'd be nice to just merge the lowercase and the uppercase y together. The same thing for the lowercase and the uppercase n. Why? If only because like literally lines 9 and 12 are identical. Lines 17 and 21 are identical. And while not a huge deal, you know, if I go in and I change this sentence, odds are over the course of my lifetime programming, I'm going to forget to change this one even though I changed this one. Or I'm going to forget to change this one and this one. So you don't want the code to get out of sync potentially. And you certainly don't want to repeat yourself. So don't repeat yourself is a tenet of programming too. If you can avoid that by somehow factoring out some commonality, you should do so, similar in spirit to math when you factor out variables or the like. So let me tighten this up, so to speak. Let me get rid of what we just did so that it's a little shorter as before. And let me express myself with 2 conditions using the following syntax. I want to check if C equals lowercase y or C equals uppercase y. So you can actually use what's called a logical operator, 2 vertical bars, which means or. And we can do this down here, or C equals capital N. So same exact functionality, but to your point, we've now eliminated what, like another one, it was like what, 4, it's like 8 lines of code now are gone, which is 8 fewer lines that I might screw up in this program, less opportunity for mistakes or bugs, probably a good thing. So now if I run this, let me open my terminal window. Let me run make agree, enter, /agree, enter. Do I agree? Capital Y. Now it seems to be handling both of those situations. So just a little tighter. As an aside, we won't use it here, but if you want to say and, which would be nonsensical, it, a little confusingly, is 2 ampersands, means a logical and, whereby the left thing has to be true and the right thing has to be true. So it's 2 Boolean expressions at once. This one makes no logical sense, though, because a character cannot be simultaneously lowercase and uppercase. It's got to be one or the other. So 2 vertical bars is logically correct. That represents our notion here of or. Question? No? Yeah? You could not write or. So I'm saying or just because that's a little more normal, but this is incorrect. However, sneak preview, in the language of Python, you actually will literally say or among other things, which gets a little more user-friendly. Other questions on this here? Searching? Yes, in back. Is there an easier way to handle case sensitivity? Yes, and we'll show you that next week, in fact. So we can combine this code to be even tighter. All right, let's do one final set of examples before taking a cookie break, if we could. But let's go ahead and close agree.c here. Let me open my terminal window, and let's go ahead and implement a sort of virtual cat as we did last week. I'm going to code up a file called cat.c, and I'm going to implement this in a few different ways, the first of them pretty foolish. So here, I'm going to include standard.io.h, no need for CS50 just yet, int main void. Inside of these curly braces, let's go ahead and do printf meow to get the cat to meow. And then to save time, I'm going to copy paste that 2 more times. So this cat shall meow 3 times in total. All right, I'm going to go ahead and make the cat, so to speak. All good. /cat, enter, and it meows 3 times, just like our scratch cat last time. I'll stipulate this is correct. This is a really well implemented cat, correctness-wise, but why is it bad design intuitively, just like last week? Sorry?
We have 3 lines of code doing the same thing.
I keep repeating the code. I mean, I literally copied and pasted, which is sort of your first obvious sign. I'm probably doing something wrong if I'm copying and pasting, because I'm literally repeating myself. So to spoil it, like odds are a loop is probably going to be our friend here. And so in fact, in C, we have those features as well. So in the world of C, we can implement some of last week's same ideas in a few different ways. These are a little more mechanical, but suppose we want to repeat something literally 3 times. Scratch gives us a repeat block with an input. So easy. C, and a lot of languages, is going to be a little more mechanical. And it's going to look ugly at first. It will take some getting used to, but it is a paradigm you will use again and again and again. This will become very rote memory before long. Well, the most direct translation of this Scratch code to C is probably something that looks a little something like this, whereby I initialize a variable, here called I, and set it equal to 3. That's the code equivalent in C of putting up 3 fingers. Then what I want to do is while I is greater than 0, that is to say, while I have at least 1 finger up, go ahead and do the following. And then once I've done that, for instance, say meow on the screen, I want to go ahead and decrement I and then do this whole thing again. Now, I could have called this variable counter for consistency with earlier, but it turns out it's conventional when you've only got 1 variable involved in your code and all it's doing is something simple like counting. You can go ahead and call the variable I for integer, for instance, but it would not be wrong to instead call I counter. But notice, too, that in this so-called while loop, as we'll start to call it, there is this parenthetical. And that parenthetical is actually itself a Boolean expression. But unlike an if statement, whereby the Boolean expression is evaluated just once, and if the answer is true or yes, you do that thing, the Boolean expression in a while loop here in C is evaluated again and again and again every time you go through the loop to check if you should keep going through the loop. So for instance, if the goal at hand is to say meow, well, of course, the comparable C function is going to be printf, and I want to print out on the screen meow, followed by a new line. Well, what's going on? Well, again, I initialize I to 3. I then check, is I greater than 0? And of course it is, because effectively in the computer's memory, 3 fingers are up. I go ahead and print out meow. I decrement I, which means to put down one of those fingers. And then I check the Boolean expression again. Is 2 greater than 0? Of course it is, so I print out meow, and then I decrement I, putting down one more finger. Then I check the expression again. Is 1 greater than 0? Of course it is. I print out meow, and then I decrement I, and now I'm down to 0. I check again. Is a 0 greater than 0? Well, no. And so the loop will automatically, by the definition of how this C code works, terminate for me and proceed to any other lines if there are more lines of code that I've written. So how do we actually implement this then in code and get it running? Well, it's going to be pretty much the same idea. Let me go back to VS Code here. I'm going to get rid of all of this copy paste. And inside of my main function, I'm going to do exactly what we saw. Int I equals 3, semicolon. While I is greater than 0, then go ahead and print out with printf, meow, \n. And then be sure you decrement I. And notice that lines 8 and 9 are not only indented, they are inside of that while loop, so to speak, which means they will both happen again and again and again, because what's happening in code here is those curly braces are kind of like the yellow pieces that are hugging the other puzzle pieces in Scratch. It will keep doing this, 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 but every time through that loop or cycle, this Boolean expression will be checked again and again and again until the answer is false, at which point the computer is going to jump to the last line. And if there's nothing left, that's it for the program. No more to be done. So same exact idea in Scratch, even though it's a little more mechanical. So that's how we might implement this. And you can think of it sort of these variables. This is perhaps a little gratuitous, but let's do this. So if you have a variable inside of a computer's memory, and that's a detail we'll get to in more detail before long, you can really think of it just as like a container that stores values. So for instance, this clear plastic bowl, it can be thought of as a variable. It just stores values. And right now, there's obviously 3 stress balls in it, so it represents the number 3. So what's really happening in code like this is we've initialized I to 3, which is this bowl. We're then checking the question on line 6, is I greater than 0? Obviously. So we proceed inside of the curly braces and we print out meow. We then decrement I. So for the sake of unnecessary drama, like that's decrementing the variable. So what's being stored in this container now is 1 less. We do it again. Check the count. Nope, 2 is greater than 0. So we keep going. Meow, decrement I. Check the variable. 1 is greater than 0. So we print meow, decrement I. We check the condition again. I is not greater than 0 because 0 is not greater than 0. And so the rest of the code stops executing. I'm not sure if that was any more effective than fingers on my hand, but we had the bowl, we had the ball. So same exact idea. Variables are just storing some value, and incrementing and decrementing would just be adding or subtracting stress balls in this case. But there's other ways we could do this. In fact, let me zoom in on my code here. And it's not really conventional in programming to count down. Like, nothing wrong with it. It's just not really a thing. We would typically count up. So we could alternatively do this. Set I equal to 1 initially. So we count 1, 2, 3, like a normal person. And we can change our condition. If I'm going to count from 1 to 3, what should my comparison be in my Boolean expression here?
I is less than 4.
I is less than 3?
No, 4.
Less than or equal to 3, I think. So if I is initialized to 1, we're going to go through this 1 time, 2 times, 3 times. I is going to eventually get incremented to 4, but at that point, 4 is not less than or equal to 3, so it's only going to execute a total of 3 times. But there's still a bug in this code. What other line needs to change? Yeah, so line 9 needs to become plus plus. So this code is just as correct, and honestly, reasonable people will disagree. Your TF might say do it this way and not this way, but like this is still correct, but it's not the most conventional way. As per last week, computer scientists and programmers generally actually start counting from 0 by convention for reasons we'll soon see. So the better way, the more conventional way, arguably, would be always start counting from 0, count up to, but not through the number you care about. And so this form of the code is probably the most popular way to do it. Start at 0, count up to 3, but not through 3, as with less than or equals than. All 3 are correct. Can't really do counting up as easily with the bowl without picking up the balls, but the exact same logic applies. And in fact, this version of the code is so commonly done that there's a different way to implement it all. There's a similar way to implement it all together. In fact, this code here, same exact thing, repeating 3 times, because it's so commonly done that you want to initialize something to 0 and keep doing something until like the value 3, you can actually use a different preposition for, which is another keyword in C, and it looks a little more cryptic, but it just tightens things up. This is what's called a for loop. Previous is what's called a while loop. And honestly, even though it probably to the newbie still looks just as cryptic, it's just a little tighter because you're expressing all of these ideas on one line. You specify the variable you want to create and initialize. You specify the Boolean expression you want to check again and again. You specify what increment or decrements you want to happen. And confusingly, you do use semicolons here, not commas. You do not put a semicolon here. You, of course, don't put them after these things. You generally only put them after functions thus far. So we do have one semicolon here. But in short, this you'll get more comfortable with. This is how I, for instance, almost always write a loop. But it's doing the exact same thing mechanically as this. Same thing as counting on your fingers. Same thing as counting the stress balls. There's just different ways to express the exact same idea. But there are ways to screw up. So in fact, let me go ahead and do this. Suppose that we'd like the cat to live as long as possible, and we don't want it to stop meowing after just 3 or a finite number of times. How can you do something forever, again and again and again? Well, let me go back into VS Code here. Let me delete all of the code from earlier. And let me go ahead and say, while something is true, I'll come back to that. Let's just go ahead and print out meow, \n, ideally forever. But what do I want to put in here? Well, if I want to do something forever, I could do something kind of stupid like while 1 is less than 2, which is always going to be the case. Or while 50 is less than 51, which is always going to be. I could just ask an arbitrary question, but like arbitrary, not good in general. Like you should have meaning behind your code. So if you want the expression to be true all of the time, just say while true, because true is not changing anytime soon. If it's literally true, it's always going to be true. The only caveat is to use this trick for now. You will need to include the CS50 library, which for today's purposes makes that possible. But there's a problem, of course. If the cat's going to live forever, if I do make cat /cat enter, like you can very quickly lose control over your terminal window. And you can see like the meows are flying across the screen, at least based on the bottom from what we're seeing. Like this cat will never stop meowing. And this is either a feature or a bug, so to speak, depending on how long the cat here should live virtually. But how do you terminate a program that is out of control like this infinitely? So one of the takeaways for today is Control-C is your friend for cancel or interrupt the program. If you ever sort of lose control over a program because you've got intentionally or unintentionally an infinite loop, you can go into your terminal window, hit Control-C, sometimes multiple times if it's ignoring you, and that will break out of the program and just essentially force quit it, like in Macs or PCs. But let's make one improvement here still. The last thing we did with our cat in Scratch, before now we'll take a break in a moment, was we defined our own functions. And recall that we did that to abstract away the idea of meowing, because Scratch didn't come with a meow puzzle piece. C definitely does not come with a meow function. We have to implement it ourselves. So quickly toward the end of week 0, we did this. Define a function called meow that just plays the meow sound. And now we have a meow puzzle piece we can use and reuse. In C, we're about to do this. And this is going to look a little cryptic, but it's going to lay the foundation for future weeks when we do this even more. I've got a meow function, weird mentions of void. That just means there's no input and there's no output for this function. It just does one thing simply, and that one thing is printf meow. So how do I use this here code? Here in Scratch is how we used it last week. When the green flag is clicked, repeat 3 times the meow function. In C, it's going to look like this, int made void and all of that. And I can use a for loop, a while loop. I'm copying and pasting the for loop version of the code. Set I equal to 0. Make sure it stays below 3. Increment it on each iteration or cycle. And just call meow. So what's nice here is that we have fairly simply a way in C to create our own functions called meow or anything else that lines up perfectly with what we did in Scratch. We'll take some time to get comfy with the syntax and remember it. Have to look it up frequently for reference. But let's go ahead and actually do this. If I go back to VS Code, clear my screen. Let me hide my terminal window temporarily. Let me go ahead and invent this meow function. Per the code earlier, I'm going to go ahead and do this. Void, meow, void. And again, the 2 voids mean no input, no output. It just does one thing well. Printf, quote unquote, meow, \n. And now down here, I can use a for loop. So for, and I know this from memory, int I equals 0, I less than 3, I plus plus. And then inside of curly braces, I'm going to go ahead and call the meow function. Notice when I'm creating the function up here, I explicitly, pedantically say void, void, no input, no output. When I use the function on line 13, you just say open parenthesis, close parenthesis. That's the equivalent of a Scratch puzzle piece without a white oval. You just put nothing there. You don't put the word void. So that's it. Let me open my terminal window. Let me run make cat to recompile /cat, and I think I have a working cat. Now this is correct. The only thing I don't love about this version, if I hide my terminal window, is that when I start writing bigger and bigger programs, it'd be nice if my main function, which I told you to sort of take on faith for today, is at the top of the file, if only because, like, literally the name main means this is the main part of my program. It'd be nice if it's the first thing I see. Which is to say, just to be pedantic, it's very common to put any functions you write at the bottom of your file, maybe alphabetically, maybe organized some other way. But you put main first by convention, just like the when the green flag clicked. It was the first thing you always started with last week. But watch what happens now. If I go into my terminal window, and Command or Control J is hiding and showing it if you are curious, but probably you'll just leave it open on your own all the time. Let me do make cat again. And I've screwed up somehow. All I did was move the meow function from top to bottom, and I'm getting call to undeclared function meow something, something, something. Well, what's going on? Well, C is pretty naive and simplistic. It's only going to do what you tell it to do, and it's only going to do things top to bottom, left to right. And unfortunately, on line 8, you are telling C, call a function called meow. But that does not exist in CS50's header file. That does not exist in standard.io's header file. It exists at the bottom of my file, at which point it's too late because I'm trying to use it before it exists. So I could just undo that and put this meow function at the top of the file. But you're going to eventually get into a perverse scenario where you can't put all of your functions above all of your functions. Like, you've got to pick a lane at some point. So the solution to this, albeit a little weird, and the one time in CS50 and programming that it is encouraged and necessary to copy paste, is what you can do at the top of your code, be above main, is just copy paste the first line of your own function. This is the so-called prototype of the function, and it simply describes how to use the function. And funny enough, we actually saw this earlier, but I kind of swept it under the rug a moment ago, or a bit ago, when we looked at standard.io.h and we looked at the printf function in the manual pages. I highlighted the header file, but I also glossed over the so-called prototype, which is, the first line of the printf function, just as this is the first line of my meow function. This is like a little clue. This is like saying to C, hey, there's going to be a function called meow that takes no input, has no input, has no output. Just know that it exists eventually. And that will satisfy the compiler. Because if I go back to my terminal, rerun make cat, it now knows on faith, per line 4, this function will eventually exist. And indeed, once it gets to the bottom of my code, line 14 onward, there it in fact is. So you just copy the one and only first line of your function's code to the top, called the prototype. And now if I do /cat, I get, finally, meow, 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 yet again in this case. Questions on these here cats? No? All right, then the last flourish, before I keep promising cookies, and I promise they exist. So last flourish, like just as we did in Scratch. So in Scratch, recall that we parameterized our meow function by letting us tell meow how many times to meow, so that we didn't need to use our loop inside of our when green flag clicked block. In other words, if I want to actually have the cat meow a specific number of times, I can actually go ahead and do that proactively with some of my own code, such as this here in Scratch. When I edited my meow function last week in Scratch, I specified that I want it now to take an input called n, which represents some number of times. And I changed my repeat block not to be 3 perpetually, but to actually have n generally baked in there instead. Or actually, instead of just saying play sound meow, I had a repeat block using n as the placeholder instead of a hard-coded 3. So how can I now use this in C? In C, it's almost the same. It's still void at the beginning of my function name, which means no output still. It only has side effects. But what did change vis-a-vis the previous version of meow? What has changed? Exactly. Instead of saying void a second time in parentheses, it literally says int n inside of those parentheses, which means in C, this function called meow takes input. It means the exact same thing as the pink on the left. And again, this is why we keep emphasizing the scratch blocks. Like, no new ideas with a lot of these features. It's just different syntax that you'll get used to over time. So if I go back into VS Code here and I change this function, let's do that. Let's change my prototype to be int n, where n represents some number of times. Let's change the actual function on line 14 to also have int n here. And let's actually move the for loop from main into the meow function, such that I now have my curly braces here. I have my print statement inside of those curly braces. And now in main, I can get rid of all of that code, just say meow any number of times, like 3. And just like I did with Scratch, let me hit enter an arbitrary number of times, sort of out of sight, out of mind. Now the essence of my program is like one real line of code, meow 3 times, because I've abstracted away the idea of meowing and told the cat instead exactly how many times to meow by way of that function.
Okay, so we have void meow, which is our prototype, right? We have our main function, which is called meow 3 times. And then in our meow function, we take an input of n for, so this would be print f meow \n. So, and then we'd say here would be less than or equal to n. I think he had a bug there. His would work because he was calling meow of 3 and he was leaving 3 there. I think it technically would work, but he needs to change this to n so it can dynamically increase according to whatever the input would have been. He had 3 here, and that he missed that in his lecture.